Welcome to the Mersenne Exponent Sum Explorer, a revolutionary tool for discovering the hidden geometric relationships between all 52 known Mersenne prime exponents. This isn't just another prime calculator. This is a visual laboratory for uncovering the unified mathematical rules that connect every Mersenne exponent ever discovered. Mersenne primes are numbers of the form 2p1, where p itself is prime. These are the largest known primes. The current record holder M52 has over 41 million digits. But here's the mystery. Despite centuries of study, no one has found a simple formula that generates all Mersenne exponents. The 52 known exponents are 2, 3, 5, 7, 13, 17, 19, 31, 61, 89, 107, 127, all the way to 136,279,841. They seem random, but are they really? Look at this pyramid. Each ball represents a Mersenne exponent, color-coded into 3 groups based on their mathematical properties: purple M01, M03, the special small primes 2 and 5 teal seed 3, 18 exponents including M02, M04, M05, M08, M09, M11, M12. Red seed 2, 32 exponents including M06, M07, M10, M13, M14. Notice the pattern. The pyramid isn't random. It's organized by digital root and last-digit properties. Mersenne exponents ending in 1, 3, 7, or 9 cluster together naturally. Here's where it gets exciting. Watch what happens when I select certain exponents and sum them. 2 times M01 plus M04 equals M05, dash 2 times 2 plus 7 equals 11. No, that's not right for M05, which is 13, but look at this. M01 plus M02 equals M04, dash 2 plus 3 equals 5. And M04 is 7. Not exact, but close. The real magic happens at larger scales. When we multiply sums by factors of 10, 100, or custom values, we find that sums of small exponents land remarkably close to larger Mersenne exponents. The differences show mathematical structure. Let me show you how to use this tool. 1. Free arrangement mode: right-click and drag any ball anywhere on the canvas. The pyramid is just a starting point. You can arrange them in circles, spirals, or any pattern that reveals relationships. 2. Selection and calculation: left-click balls to select them. The app instantly sums them, applies your chosen scale factor, and checks against prime sieves. It even finds the nearest actual Mersenne exponent and shows how close you are. 3. Layer system: this is crucial. You can save any arrangement as a named layer, spiral pattern, sum search one, whatever you want. Export layers as JSON files to share with other researchers, or import their configurations. You can instantly switch between different geometric arrangements to compare patterns. 4. Scale factors: the scale multiplier is your experimental variable. Try times 1, times 10, times 100, or custom values. Watch how different scaling reveals different relationships between small and large exponents. 5. Prime sieve filters: the app automatically tests sums against essential prime filters. Last digit must be 1, 3, 7, or 9, and digital root cannot be 3, 6, or 9, with the exception of 3 itself. This is the ultimate goal. Find a simple, unified formula that generates all 52 Mersenne exponents. We're not looking for new primes. We're looking for the mathematical rule that was always there. The hypothesis is profound. All Mersenne exponents can be expressed as sums or linear combinations of smaller exponents, multiplied by specific scale factors. Think about it. If we can express M52, 136,279,841, as some combination of M01 through M05. If every new exponent follows the same pattern as the previous ones, then we've found the hidden structure of Mersenne numbers. The geometry helps us see which exponents are close to each other, which form natural groups, and which distances repeat across the entire set. Here's how to use this app for serious research. 1. Start with small exponents. Find relationships between m0, 1, m10, 2. Test scale factors. See if multiplying sums by 10k lands near larger exponents 3. Document everything. Save each promising configuration as a layer 4. Look for distance patterns. Are gaps between exponents multiples of each other? 5. Check digital roots. All Mersenne exponents except 3 have digital roots 1, 2, 4, 5, 7, or 8. The app tracks the distance to the nearest Mersenne exponent for every calculation. When that distance is 0 or very small, you found something significant. Watch this example. Select M012, M035, M0513 sum equals 20, nearest Mersenne is M0719, just one away. With scale times 1, 20 right arrow M07 is 1 below. Try different combinations, and watch the patterns emerge. The nearest result feature is your compass. It tells you when you're getting warm. This is open source mathematics. The Mersenne Exponent Sum Explorer puts 52 data points and infinite geometric arrangements at your fingertips. Download the HTML file, save it to your computer, open it in any browser, no installation needed. Export your findings as JSON, share them with the community, and let's find that unified rule together. The pattern exists. We just need to see it from the right angle. Start exploring. Start discovering. The geometry of primes is waiting. Goal: find a simple unified formula that generates all Mersenne exponents through sums and scaling of smaller exponents. Not a prime finder, a pattern finder.